we're going to do the 2003 AP Calculus AB question number 1. So it says, let R be the shaded region bounded by the graphs of y equals the square root of x and y equals e raised to the negative 3x, and the vertical line x equals 1 is shown. Find the area of R. Okay, so this part is the square root of x. The bottom is e to the negative 3x, and this is x equals 1. Okay, so when I find my area of R, I'm going to do my top curve minus my bottom curve. So I have square root of x minus e to the negative 3x. And my x values go from right here to 1. So I need to find what that point is. So go ahead and put square root of x in for your y1. Okay, and then I'm putting e raised to the negative 3x in for my y2. Okay, and I'm going to find where they intersect. Okay, I need to zoom in a little bit. So it's going to say first curve, so hit enter along the first curve, move along the second curve, hit enter, just guess where you think it is. So when I did that, I got to that point there. I got it was 0.23873,413, comma, 0.48860,427. All right. And I want to store both of these values because I could use x, I could use y. I'm going to store this one as a and store this as b. So in order to do that, go back to your normal screen that you're always on. And you're going to hit x and enter. So hit x and then enter. When you do that, 0.238734123 comes up. All right, I'm going to hit store, which is the button that looks like stow. So store. And I'm going to store it as alpha A. So now whenever I come back to that, it's just going to be equal to A. Okay, I'm going to do the same thing for the other one, but now I have to hit Y, so do alpha Y. And now I'm going to store that, so store as alpha B. Okay, so now that Y value is now stored as B. So if I ever need those throughout my problem, they're stored as A and B. So the nice thing about that is now I can write, so that's A, this height is B here. Now I can write A instead of writing 0.23873, so on, down here. All right, so my area is, so I guess here maybe I should write area since I have A. I don't want to be confused with A and A. All right, so when I integrate, you can do this on your calculator, so I hit math and then 9, so finite integration. And I have those stored as y1 and y2. So on my calculator, here's what it's going to look like. I'm going to hit f(int). I'm going to do y1 minus y2, comma, x goes from a to 1. Okay, so I'm going to hit variables, so VARS, arrow over to y variables, function y1, minus variables, arrow over to y variables, function y2, comma, x, comma, alpha a, comma, 1. So when I do that, I get 0.442629, so I'm going to say 0.443. Okay, for part B. Part B says, find the volume of the solid generated when R is revolved around the horizontal line, y equals 1. Okay, so y equals 1 is up here. Okay, so I need to think about what my outer radius and inner radius are. So start at your horizontal line. My outer radius goes all the way down to that outside curve. So I call that my capital R. My inner radius is my little r. So that goes from where I started to the inside curve. Okay, so capital R is going to be, this was 1, so 1 minus the bottom curve. That was e to the negative 3x. My little r, so my inner radius is 1, so top, minus the bottom. So this bottom curve was square root of x. So when I set this up, I get my volume is equal to pi, so pi is on the outside, outer radius squared minus inner radius squared. So that way it's pi capital R squared minus pi little r squared. So I have 1 minus e to the negative 3x squared minus 1 minus the square root of x squared dx. And my x values go from a to 1. So input that. Not one that you would want to do by hand, definitely. Okay, so when I do this, I got 0.45313 and so on pi. Or when I multiply pi n, 1.4235, so I'm going to say 4. So 1.424. You could also have 1.423 if you just truncate. So that's your answer for part B. All right, now part C. Part C says the region R is the base of a solid. For each solid, each cross-section perpendicular to the x-axis is a rectangle whose height is 5 times the length of its base in region R. Find the volume of the solid. Okay, so let's erase some of this. So I'm going to go perpendicular to the x-axis. So here's what my cross-sections are looking like. Okay, and these are always really hard to draw, but in class we did like the manila folder thing. So if we have little pieces of manila folder coming off these, the height is 5 times the width. Okay, so for each cross-section, your width, that's just, I'll draw it in red, that's from here to here. So it was your top piece minus your bottom piece. So it was square root of x minus e to the negative 3x. And your height is just 5 times that. So if I multiply those two together, it's just 5 and then square root of x minus e to the negative 3x squared. Okay, so that's my area of each cross-section. When I add up all those areas, it's integrating. So it's finding the summation of all those. Okay, so here's what I'm going to have. So I'm going to have volume equals the area of each cross-section. So I'm going to have 5 times square root of x minus e to the negative 3x, and then times another one of those, so I'm going to square it. If you go back and look at your picture, your x values go from that point, which we found before, to 1, so a to 1. Okay, so when you put this in for Math 9, you get 1.554 for your answer. Okay, so that's your answer. Okay, so let's look at our different points and see if we got all of them. Okay, so part A, well, first of all, we get 1 point for having correct limits and integral in part A, B, or C. So if we had from T, they called it T, we called it A, so A to 1. So 0.238734 to 1. Then you got 1 point for that. For part A, you get 1 point for setting it up correctly, 1 point for your answer. We had that correct on both parts. Part B, you get 2 points for having the integral set up correctly, 1 point for your answer. And part C, 2 points for setup, 1 point for answer. We did get all of those points.